Alright, we are on our third section. This is the fourth section in the textbook, though. And we're combining a little bit out of that third section because we didn't talk about monomials. So the last video talked about prime factorization, but it didn't include monomials in it. So we're going to talk about monomials, what it means to factor those, and then we're going to talk about multiplying and dividing those. So a monomial is simply a number, a variable, or a product of numbers and variables. So anything that you're multiplying together is a monomial. So for instance, 5, simply a monomial. X, monomial. 4x, because you're multiplying those two, it's a monomial. 10x, y, z, doesn't matter how many you have, as long as you are only multiplying, it's a monomial. If I start to add things, so if you want to write these down, you could say not monomials. And this would be x minus 5, 10x plus 7. Because there's addition and subtraction, that does not count as a monomial. It has to be multiplication or just simply a number or a variable. So when we look to factor these, let me get a better marker here. When we look to factor these, all that means is we're breaking it up into non-exponent form. Well, numbers will be in prime factorization exponential. Variables will be in non-exponent form. So this, 11 is already a prime factor. So that one's just going to stay. We can just write 11 times, and the r is to the fourth power, so we're going to write out r 4 times. So we just break this out into standard multiplication format. And then we just have one s, so we just write an s. So the factor form of 11r to the fourth s is 11 times r times r times r times r times s. So it gets trickier when you have numbers that can actually be factored. So negative 28. Negatives get factored out as a negative 1. So anytime you have a negative number, that has to become a negative 1. Times, now the prime factorization of 28, we can break that down into 7 times 4. The 7 is prime, the 4 goes into 2 squared. So those numbers you are allowed to use powers on. So 2 squared times 7, but the variables lose the exponent. So there's 2 a's and then 3 b's. So it's not very hard. It's just a little different. We hadn't talked about some of the terminology of all of that. So that's the only difference that we have there, is that the numbers can use a regular prime factorization, use exponents, and the variables, we take away the exponents and write it in standard multiplication form. Okay? So make sure you have those all down there. So that finishes out that prime factorization piece. And now we're going to actually talk about how do we multiply and divide monomials. To multiply and divide monomials, we simply, to multiply monomials, add the exponents of like bases. To divide, subtract the exponents of like bases. So copy those down, and then we'll talk a little bit about what that means. Alright, So I didn't give you the names of those are actual like properties in algebra. I didn't worry about the names of those for now. However, so I'm going to look at an example of this. So we're on example 2 here. So if I have, for instance, 4 squared times 4 to the third, what we're looking at here and what this really means is when you look at this, this is really like saying you have 4 times 4 times, and then we have 3 more 4s, right? So how many 4s do I have in total? Well, we have 5. So this becomes 4 to the 5th power. 2 plus 3 is 5. So when you have the same base, you add the exponents. So multiply, you add the exponents, and this is why. Because when you separate it out, you're just combining the two numbers. Same thing happens for variables. If I have x cubed times x to the 7th, what this means is I have x times x times x, and then we have 7 more. So how many do I have in total? 10. 3 plus 7. Now we can do it all together. We can have exponents and, variables and numbers. So if I say, let's see, yeah, we'll do 11 x to the third times, we'll do it this way, parentheses, times negative 4 x to the 5th y. So I just boosted this quite a bit. So we threw all kinds of things in there. We simply multiply. So when you have the numbers, they're not like bases, but we're still multiplying. So 11 times negative 4 is a negative 44. X cubed times x to the 5th, add the exponents, so we get x to the 8th. There's nothing else to multiply the y by, so it just stays as y. And that's as easy as it gets. Or that's really as hard as it's going to get, so it's not very hard. So let's take a look at when we divide. So I'll show you some examples, then I'll have you do a few on your own. So example number 3. For instance, if I have c to the 7th divided by c to the 4th. What happens here and why we subtract on these ones is what this means is we have c 7 times over c 4 times. Remember, if something is on both top and bottom, you can cancel it, right? It becomes 1. So we can cancel, 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 cancel. Well, what am I left with? 7 minus 4. And then technically you could say it's over 1 or just c cubed. It's all the same. So let's do another one. And again, this could be with numbers as well. So I could say 7 to the 8th over 7 squared. Well, that would be so we cancel 1 from top, 1 from the bottom, and we're left with 6 left over. So we have 7 to the 6th. And again, this can also work, so I'll squeeze this last piece in over here on the side. This can work if you have both numbers and variables on top and bottom. So if I have 18 x to the 5th y squared all over 9x y squared. Actually, let's just make that y. So 9xy. Again, 18 and 9 are different, but you can just go ahead and just divide them. 18 divided by 9 gives us 2. X to the 5th over x, remember this is to the first, so that's going to be 5 minus 1, x to the 4th, 2 minus 1 is 1, or just y to the first. So then we end up with 2x to the fourth y, and that's our answer. So again, that's as complicated as it's going to get for now, and it's not even that hard. All right. So let me get you a couple of examples here. So if I have 10x times 4x to the 7th, and the directions on something like this would just say to simplify. And so when it says to simplify, that just means you're going to either multiply or divide depending upon what they give you. So then we're going to have m to the 5th times negative 6 m to the 4th. Letter C. Let's do 5 to the 10th divided by 5 squared. And the last one, let's do x to the 11th divided by x to the 4th. So take a minute, and you're going to want to pause the video because I'm not going to give you a ton of time. But take a minute, figure those out, and then when you've figured them out, go ahead and push play again, and you can check your answers. Alright, so check your work, see how you did on those. Hopefully you did pretty well. And that is the extent of multiplying and dividing monomials. So really we're just kind of getting an introduction here to some rules of exponents. Next time we will talk about negative exponents, and now that you understand kind of how we multiply and divide, negative exponents will make more sense and you'll kind of see where we're headed with that.